The CNC router is ready. The last step to make this CNC router work is firmware. This video will focus on axis motion. Hi, welcome to Slow Engineering. I'm David. Before directly diving into configuring all the detailed settings in Marlin, let's introduce how to set up the environment for editing the firmware. Marlin firmware is a C++ based program with many files. For most application users, developers prepare two files for users to configure for their machines. The files are configuration.h and configuration.advanced.h. I used the Visual Studio Code with extensions to build my settings this time. After installing Visual Studio Code, head to the left toolbar and find the extension icon. Search Auto Build Marlin and install. Next, search Platform I/O and install the extension too. These extensions are needed when building the firmware. After installing the extensions, download the firmware from the Marlin download page, extract the download file, and open the folder in the Visual Studio Code. You should find the two configuration files in the Marlin folder. Later, when finishing the editing, head to Auto Build Marlin for a firmware build. If the build succeeds, copy the binary file into a micro SD card and insert it into the card reader on the board. LED blinks when flashing the firmware. This procedure will repeat several times with testing to get suitable values for configurations. About testing, I use PrimRun on my PC and connect to the board via USB. You will see the PrimRun screen in the following configuration process. Marlin is also known as 3D printer firmware. In the configuration files, you will see lots of 3D printer settings. This time, as a CNC router setup, I will ignore most of the 3D printer component settings. Start with the configuration.h file. This file includes the most basic settings for the machine. First, you might want to give a name for these changes. If you scroll down a bit, you will see the definition of the motherboard. The comment above guide me to find the board I used. The board.h file is located at Marlin src cord. Utilize the searching function by pressing Ctrl+F to find the specific board. Copy the name or the defined value back into the configuration file. The next step is to define the serial port. I plan to operate the CNC router with the PC, so I set the serial port for USB only, and its value would be -1. After that is the serial port baud rate. Leave it as default unless encountered dropouts in the future. Move to the stepper drivers. I fill TMC 2209 drivers here with my board. The detailed settings for TMC drivers will come up later. Scroll down to the next sections of extruders. The CNC machine has no extruders, so remember to set the number to 0. Let's skip multi-material settings, switching tool head, and so on for 3D printer. The next step is thermal settings. I don't use a thermistor here. Set the temp sensor 0 to 0 for the CNC machine. Ignore the following settings and go straight to the Endstop settings sections. Here are the Endstop positions. Uncomment the corresponding Endstop locations to tell where they are. Like my build, I placed the limit switch at the maximum X and Z axis position, but I placed the Endstop at the minimum position on the Y axis. Below are pull up and pull down settings. As I mentioned in the previous video, an NC setup for limit switches is more robust than an NO setup. You can also find out all the Endstops are set to pull up as default on Marlin. If you are using NO setup, you might change all the Endstops to pull down, or comment on both of them to make custom settings individually. The following sections describes the hit or triggered states for switches. For the first time, You might be confused about these settings. Leave all the settings as they are and flash firmware first. In the testing scenario, command M119 will report the triggered or open state of the endstops. By triggering the switches manually, I can find out the correct settings to match the states. Passing over some green comments. Step per unit are the microsteps for each unit. These values tell how many steps should proceed as the millimeters goes. As I also explained in the video before, the term for the stepper has a total of 6400 microsteps, and the lead for the bolt screw is 10 mm. It means the steps per millimeter is 640 microsteps. The upcoming part is the feed rate, or also called the access speed. These values also need to be tested back and forth to have suitable values. The unit is millimeter per second, combined with the accelerations below, which also needs tests to determine the values. The goal is to find a speed without stepper skipping in the movements. Higher accelerations cause more obvious vibrations when changing the tool path. Into the homing section. Homing is used to give a positions when the machine is powered up, unlike machines with absolute encoders. These machines must home every axis before further operations. The first settings are the homing directions. They are based on where the endstops are on the axis. Then, the size of the printable area. The printable area is to the 3D printer as the working area is to the CNC router. The travel limit below defines the actual working volume of the machine. The actual working volume might change depending on where the limit switches are and the assembly. Use the M114 commands when testing to determine the range of each axis. Make a large move to the Z-Save homing section. Find a line named homing speed. Fill in the homing speed feed rate. It is noticeable that the unit is different from the feed rate before. It turns into millimeter per minute. Lastly, the detailed settings for the TMC series stepper drivers are in the TMC Smart sections of the configuration advanced.h file. Steppers currents and microsteps are also set here. This is the part of the XX motion test and firmware configuration. I hope you enjoyed. If you have any suggestions about this CNC router, please comment below. Like share this video if you think it's helpful or learn something. Subscribe to this channel to get more project content in the future, or consider becoming a Patreon member to unlock more content and support future projects. Thank you for watching and see you next time.